Hi everyone, welcome to the second part of this series of designing a chat application. So in this video we will be looking into a high level designing of our chat application. So the first question which comes to our mind is how does two clients or two users communicate among each other in order to send messages. So it has been found out that the clients basically maybe a mobile application or web application, they are trying to communicate with each other, and clients do not communicate with each other directly. So one important is like we have clients. For clients, this is basically a web app or mobile app, and the clients don't communicate directly. This is because of security and scalability issues and reliability. Don't we use a server in between to establish the connection between two clients or between two users to send and receive messages. So they don't communicate directly. So instead what they do is they communicate with the chat server. So suppose I have this client, and what it does, it sends a message. This is let's say my chat server. Chat server mainly performs two functionalities. One is like store the message, or in case the other user or the receiver is offline, or relay the message, basically send the message to the right recipient. So this is my receiver. So this is a basic overall view of how clients communicate, sender and receiver communicate. So this is our sender. So now let's look into a high level overview of the network protocols which the sender uses to communicate with the server and the receiver uses to communicate with the server. So let's look into the network protocols used for communication. So for sender to send a message to the chat server, so it first uses, let's say it basically uses so it wants to send a message to the chat server. So it uses a HTTP protocol or HTTPS protocol along with a keep alive header, which is supported in HTTP 1.1 version, keep alive header. So this is used in order to avoid recurring connection establishment between sender and chat server, and to keep alive and to avoid multiple TCP handshakes, thereby increasing the latency of sending messages. Thus we use a HTTP protocol. This is supported in HTTP 1.1. So we use a HTTP protocol along with the keep alive header. So this helps to persist the communication between the sender and the server to reduce the TCP handshakes. But the next question is, how does a server connect with the receiver? So this is the sender connecting with the receiver using a HTTP protocol and the keep alive header. So this is done. So our next would be, how does, this is my chat server now, communicate with the receiver? So chat server cannot communicate with the receiver using a HTTP connection, because as we know that HTTP is a client driven protocol. So basically HTTP protocol not supported from the chat server side, because this is a client driven protocol. It helps servers to scalable instead of managing the client information at its end. Moreover, there are many firewalls and NAT which blocks the connection for security reasons, and maybe the receiver is offline, the server is trying to connect, and client server is also having the client is also having a dynamic IP, and so there are many problems. So for this we avoid a HTTP connection from the server to the receiver. So but for this, so for a workaround, what we use is we use a, let's say, a pooling mechanism of connection. So in this what happens, the receiver on the other end The receiver can connect with the chat server using a HTTP protocol. So receiver on the other end tries to connect with the server by establishing connection using HTTP protocol and TCP handshake in order to check whether there is a new message or not, and the server responds with, let's say, if there is no message, and it responds with a no, and the connection is closed. And this continues for a longer period of time or for multiple in a frequency interval until the server has a message and the client receives a message with a yes response. So basically this is client periodically asking server if new message found. So in polling mechanism, what happens is client or the receiver asks the server if new message found, and the server every time responds with a no until and unless there is a new message and the connection is closed. So every time the client has to establish a connection with the server, do a TCP handshake and check whether there is a new message or not, thereby incurring a lot of latency. So this is a costly operation if these are the cons. So this is the disadvantage of the polling mechanism. So this is a costly operation since depending on the polling frequency. So for this, what we have is, we can also, as a solution, we can use a long polling mechanism. In long polling mechanism, the connection is not broken down between the receiver and the server, where rather what happens is, once a receiver establishes a connection with the server, the connection remains until and unless a new message has come or a threshold period has been overcome, or threshold period has been reached, whichever is earlier. So in long polling mechanism, what we have is a client connects with the server and persists the connection till either new message found or threshold period reached. Okay, so new message found, threshold period reached, whichever is earlier. And in this way, we have a probable solution for this disadvantage of this polling mechanism. But there are also disadvantages of this method also. So let's say one of the major cons is like server or receiver, there is a sender and the receiver do not communicate with the same server. So in that case, although the sender has received the message, but the receiver connects to a different server and it finds that there is no message, and this is a disadvantages or bad situation which will occur in this long polling mechanism. So let's say what we can say is sender or receiver connect to different servers. Moreover, the server cannot tell whether the receiver is disconnected or client is disconnected or not, and the server is holding the connection. This is also a disadvantage. Server cannot tell if receiver is disconnected or offline. And the user doesn't chat much. Suppose there is no much communication between two users, but the long polling still makes periodic connection with the server after a certain timeout. So this is an inefficient operation or a costly operation. So this is also a disadvantage, like users don't chat much, but long polling makes communication after the threshold timeout since no message has been found. So this is an inefficient or costly operation. So these are some of the disadvantages of long polling mechanism. So for a workaround of these two, polling and long polling mechanism, what we have and what we actually use is a WebSocket protocol, WebSocket connection protocol. So this is the third, and this is the WebSocket protocol. So WebSocket is a connection which is initiated by the client, and this is a bidirectional and persistent. So the connection is initiated by client, and once the connection has been established between the client and the receiver, so client and the server, sorry, so this is bidirectional, so both can communicate with each other, and the connection is persistent. So how does it work is like WebSocket handshake happens is it uses a TCP handshake. So basically it initially sends a HTTP request along with additional parameters in the header. So WebSocket, if we discuss in little bit brief how it works, WebSocket handshake. So WebSocket handshake happens is like it is a basically HTTP protocol. It uses underlying HTTP protocol. Thus there is a TCP handshake to establish the communication, and along with the HTTP request we have additional headers. So like HTTP get, and we have WebSocket protocol or WSS for security, WebSocket secure. So we have, along with the headers, we have additional headers in the HTTP request which tells the server to upgrade the communication to a WebSocket protocol. So we have upgrade as the header, and another is the connection, that is upgrade. So these two are the main headers which tells the HTTP connection to be upgraded to a WebSocket protocol, and once the server acknowledges the request using the token and the security methods, and it establishes a connection and upgrades the HTTP connection to a WebSocket protocol. And this even works even in the firewall protected servers or the client side. Basically it uses the port 80 or 443 port, which is basically for HTTP and HTTPS connection, and it works for firewall. It works for even firewall present because it uses 80 or 443 ports, which is the HTTP or HTTPS port, and it used for both sender and the receiver side, used for both. So earlier, mind you, we discussed like sender communicates with the chat server using HTTP protocol, but it has been found out that WebSocket protocol can be used for both sender side and the receiver side, and thus we use it for both sender and the receiver to communicate with the chat server. This is important upgradation which we have. And since connection is persistent, efficient connection management is critical on server side, so that the connection is not being held up for a longer period of time, even when both the receiver or the sender has been disconnected or they are offline. So this efficient connection management is to be done. Efficient connection management. So thus we use a WebSocket protocol to communicate with the chat server for both the sender side and both the receiver side, and mind you, this is bidirectional and the persistent connection. So this is important, bidirectional and persistent connection. So now we have established, or we have seen how senders and the receiver communicate with the chat server, but there are other factors also in a chat application, like user logs in, users friend list, etc., and user preferences, user settings, which needs to be done depending on the user's activities on the chat application. So those connections, for perform those operations, not everything has to be a bidirectional connection. So for like this is a note, although the connection between the sender and the receiver with the chat server is bidirectional, not every connection in a chat application is bidirectional. Not every connection in chat application is bidirectional. So which are not bidirectional? Like most features like this sign up or login or user settings, user profile settings, etc. This can be done with using the basic HTTP connection which we had earlier seen. So if I distribute the chat system design into 3 categories, we will see we have one is the stateless service. So what is the stateless services? And what we have in this stateless service, in this we have the user facing request or the response service, like these are user facing request or response service. What is this? What does it mean? Like we have these various requests like login or the sign up, user profile, etc. And this lies behind a load balancer. So whenever a particular user performs this or requests this operation, the load balancer sends the request to the particular application handling this request, particular server handling this request, or rather service handling this request. So these services can be, so this lies behind load balancer. These services can be either monolithic or microservices, depending on our use cases. So this is one is the stateless service, another is the stateful service. So the connection between the client and the connection between the sender and the receiver with the chat server is a stateful service. So this is basically the chat service which we discussed just above. So why this is called stateful? So why stateful? Because we persist the communication. So basically the communication is persisted between the sender or receiver and chat server using the WebSocket protocol. So for this to select the particular chat servers, we use a service called service discovery. So we will be looking into next about this in details in our deep design dive video. So in the next video basically. So this is it coordinates closely with the chat service to avoid server overloading. So we will be looking about this. And the third which we have is the third party integration or the notification services. So we have third party integration. This is basically the notification services which we have seen, and you can read more about it, and or you can watch the playlist of designer notification system to dive deep into how notification system works. The link for the particular playlist will be provided in the description box. So these are the 3 categories in which we can divide our chat system. And the next thing which we'll be looking into, the scalability, how we scale our chat application. So one of the limiting factor which we will have with our server is like the concurrent connections which the users, the receivers or the senders tries to have or establish with the chat server. So this will be one of the limiting factors. So let's say suppose we have concurrent users of 1 million. So what will be the limiting factor for which we need to scale our application basically? So the number of concurrent users trying to establish or communicate with the servers. So let's say in our case we have 1 million concurrent users, and suppose each connection requires 10 kilobytes of memory. So for 1 million, 10 to the power 6 and 10 kilobytes, we will have approx, this is 10 GB of memory is required for a particular server to handle 1 million concurrent connection. Although this is a short amount of memory and this can be handled by a single server, but having an application which is working on a single server is not favorable designing. So about this we can discuss with the interviewer during the interview regarding how many servers do we actually need. This is a rough estimation, and depending on the use case you can deploy more number of servers and choose the best server to communicate between the receiver and the sender. And we also store the chat history, using a key value store. So whenever a user comes off online and a user is particularly offline and it comes online, so we can retrieve that chat and send the chat to the particular user. So now let's talk about the third thing of this high level design is the storage. So we discussed about the network protocol or the connection. Second, we discussed about scalability. Now we discuss about storage. So what do we use for do we use a relational database or non-relational database? So let's look into the data type depending which we will be using our database. So for a chat application we have basically two types of data type. One is the generic data. So by generic data I mean the user profile, user data, his settings, user preferences, user friend list, etc. So user profile, user settings, the friend list, etc. So this to support this kind of data, our database should be robust and reliable, and it should also support replication and sharding for high availability, replication and sharding for high availability and faster access and scalability. So for this we use a relational database. A relational database basically supports this kind of data. And another data which we have is the chat history, which we just discussed about using a key value store. This data, chat history between two users or between a group. So this chat history, if we discuss, I'll discuss here chat history. A lot of factors are working behind to decide which kind of database which we use. So one is like the read-write pattern. So read-write pattern is like for in a marketplace, like for applications like Facebook, WhatsApp, 60 billion messages are handled every day, and we access the recent chat history. Recent chat history is accessed frequently, but the older chat history, for that what we also do, we can also access the older chat history using the access older chat history using the search bar or the mentions, etc. So thus we need to store all of this data in our database in order to retrieve fast, and the read is to write operation is almost 1:1 for 1:1 group, 1:1 chat applications or group chat. So for considering all these factors to decide which database we will use, we choose the key value store. So key value store has number of advantages like horizontal scaling, easy accessibility of data. The RDBMS is, that is the relational databases, cannot handle long tail of data. Thus indexing is expensive. Thus faster data access or data retrieval is slower. We have also seen like in real world applications like Facebook Messenger and Discord, they use key value stores. Like Discord uses Cassandra, Facebook Messenger uses HBase, etc. So to learn more about horizontal key value store, you can see my playlist of designing a key value store. So key value store has some of the advantages like horizontal scaling, easy access of data, and these are adopted by industry use cases also. So thus we use both RDBMS, relational databases, and NoSQL or key value stores to store our different kind of data. And lastly, we will discuss the data model, like how we store the data in the databases. So what is the schema, what is the table column types, etc. So one is the message data, 1:1 chat message data. For this, our primary key is message ID, and second is we have group chat data. So this is, for this we have a composite primary key. One is the channel ID and the message ID, and this is our partition key basically, which is used as a key in the key value store database. So message ID, basically how this message ID should be, this should be in both the cases. Message ID should be ordered in the way the messages have arrived. Order of messages should be increasing with time of arrival. That is that makes it unique and sortable. So for this, what we can use is, one is we can use auto increment, which is generally used in RDBMS like MySQL and all. So this is not actually supported in key value store. To learn more about it, you can see my how we design a unique ID generator, where I have discussed about the auto increment feature, why it is not in use in key value store, not supported in key value store. Second, for this we can use is the 64-bit snowflake approach, which uses timestamp to generate the unique ID. Another is which we can use is, and this is actually used in real world scenarios, that is the local sequence number generator. So these are basically IDs which are unique within a group, and maintain message sequence in 1:1 channel or group channel is sufficient. So these are unique within a group, and to maintain message sequence within 1:1 channel or a group channel is sufficient. Maintaining message sequence in 1:1 channel or group channel is sufficient. So in this way we store the data in the databases. So this is the data model. We use a channel ID and a message ID for a composite, as a composite primary key for group chat data, and message ID as the primary key for 1:1 message data. So this is an overall high level overview of a chat application designing. So in the next video we will be diving deep into certain components of a chat application. So thank you for watching this video, and I will see you in the next video.